Build new shapes. Use smaller shapes. Composite shapes form.
It's golden hour at the Willow Bend Pond, and Willow the beaver has a problem. Her mud and stick lodge needs immediate mending. Her available resources seem limited. She only has small, flat river stones shaped like triangles, squares, and half circles. On their own, they look entirely too small to fill the gap. The wise math Sheba watches from the bank. From this vantage point, the potential in those scattered stones becomes clear. There is a core operational rule to building with shapes. When you push two flat shapes together, edge to edge, with absolutely no gaps and no overlaps, they join to create one entirely new shape. When organized this way, individual stones transform into structural components capable of filling any gap. Let's look at Willow's first repair. She starts with two identical flat stones, both shaped like triangles. Notice how each piece possesses one distinctly long, straight edge. Watch what happens when she places those pieces on the muddy bank and slides their longest edges together. The gap between them perfectly closes. This animated diagram shows exactly why a square appears. Because those long edges meet seamlessly, the four outside edges are completely equal in length, and every corner forms a perfect right angle. Even though the perimeter changed, the original pieces exist inside. Two triangles compose one square. Once you understand that a square contains a hidden diagonal seam, you can break down and rebuild right-angled structures at will. Moving to the next gap, Willow picks up two new stones. These are half circles, and their anatomy is slightly different. Each piece features one flat, straight side and one continuously curved, round side. To make these work, the alignment step is crucial. She has to match the two flat edges side to side so they touch all the way across. Looking at this diagram, the outcome of that alignment is clear. Once the flat edges lock, the two independent curved edges swing around to meet, creating a single continuous loop. Two half circles compose one whole circle. Building round objects doesn't require a curved mold. You simply have to identify their straight halves and reconnect them. Now Willow faces a much larger, square-shaped gap in her lodge. For this, she only has 4 small square stones, all exactly the same size. She handles this strategically. She starts the top row by placing 2 squares perfectly side by side. Then she places the remaining 2 squares directly beneath that first row, packing them firmly into a 2x2 formation. This animated grid shows the proportional logic of that arrangement. Because those 4 equal squares completely fill a space that is exactly as tall as it is wide, they generate a mathematically identical shape, just scaled up. 4 small squares compose one larger square. Scaling up a structure doesn't mean you have to go out and find massive materials. It only requires organizing a larger quantity of uniform pieces into an even grid. For her final challenge, Willow attempts something slightly more advanced. She combines 2 completely different shapes, one square and one triangle. She sets the square stone flat against the mud first, providing strong vertical sides and a level top edge. Then she takes the flat bottom of the triangle and sets it precisely on top of the square's flat edge, patting it firmly into place. By combining those 2 distinct shapes, an entirely new outline takes form, a highly recognizable house shape with a pointed roof. Mixing these different geometric blocks along matching flat edges creates a variety of new outlines, each defined by how the pieces meet. The lodge is completely mended. The edge-to-edge rule worked, leaving these perfectly fitted geometric shapes glowing gently against the mud wall. Identical triangles became squares. Flat-edged halves formed circles. Small grids scaled into larger structures, and mixed shapes built new outlines. The Sheba looks at the mended wall one last time. Every shape Willow built started as a set of separate pieces, and those pieces are still there, hiding in plain sight. The next time you see a structure in your own world, try to look past the outside edges. If you look closely, you can find the hidden geometric pieces living inside.
2 triangles join. Make a rectangle. Shapes compose together.